Hello students, we had completed our first chapter, rational numbers. Now here we are to begin the second chapter. The name of the chapter is, as you can see on the board, linear equations in one variable. You must have faced such equations earlier also. You must have some idea about these equations. We will study a lot more about such equations. This is a very interesting chapter and very important chapter. Because without solving the linear equations, you can reach nowhere in mathematics. Literally nowhere. Everything that was to be done without these equations is over now. Coming forward in standard 8th, 9th, 10th, you will face such equations everywhere in each and every chapter. Whether it is geometry, whether it is statistics, or whether it is any other chapter. Everywhere you will face such equations. So it's very important to understand these equations, and it's very simple. Actually, these equations are not to confuse you, not to puzzle you. These equations are actually defined or designed to make your calculations much easier, as we'll see in a slight while. Okay, let's see the first example that's there on your screens. A train leaves from Chandigarh to Delhi at 7 a.m. at the speed of 70 kilometers per hour. Another train leaves from Delhi to Chandigarh at the same time at the speed of 85 kilometers per hour. The distance between Chandigarh and Delhi is 310 kilometers. Okay, this is the situation given now. There is a place called Chandigarh. Let me just draw it. There is a place called Chandigarh. Let's say this is our Chandigarh and this is our Delhi. Okay, let me just label it. Chandigarh and Delhi. The distance is given to be 310 kilometers. Okay, let it be here. And now see, there are two trains. One is going towards Delhi at the speed of, from Delhi to Chandigarh. Let's draw it, it will be better. I'll draw the two trains in two different colors. Let's say the first is red. Red train is going from Chandigarh to Delhi. Now it's moving from Chandigarh and it is going towards Delhi. What is the speed of this train? 70 kilometers per hour. Okay, I'll just write 70 over here. The other train, I'll draw it in green. This is going from Delhi to Chandigarh. From Delhi to Chandigarh. Okay. What is the speed of this train? The speed of this train is 85 kilometers per hour. Isn't it? Now, the distance between the two places is 310 kilometers. 310 kilometers is the distance. Very familiar scenario. Each and every railway station you see trains going from one station to another and coming back from there. Every day it happens. Now one particular case is given here between Chandigarh and Delhi. The speed of the two trains are different, but the timing is the same. They start from their original station at the same time. So before we get into the question, we'll solve the questions later. But just tell me first. Both the trains start at 7 a.m. and it starts from 7 a.m. here also and 7 a.m. here also. So both of the trains are starting at the same time. Will they reach at the same time? The first train which has to come from Chandigarh to Delhi, and the second train from Delhi to Chandigarh. Will both of them reach at the same time? They have started at the same time. Does that mean that they'll reach outside at the same time? Okay, let's just do a quick calculation. That's a very simple question. What is the distance to calculate? What's the formula to calculate the time? What's the formula to calculate the time? I'll just write it here. How do we find time? We know from the previous classes, time is equal to distance upon speed. Time is equal to distance upon speed. Okay. So with this formula, we can calculate the time. What's the time for the first train? Distance is 310. So speed time will be 310 divided by 70. What will that give us? 31 divided by 7. That's equal to 4 hours and 4 and 3 by 7 hours. Isn't it? And for the second train, this train, the distance will be time will be 310 divided by 85. What will this give us? Cancel out 5. 62 divided by 17. 3 hours 11 by 17. 311 by 17 hours. Now, very clearly, this is taking more than 3 hours and this one is taking less than 4 hours. Isn't it? So, they will not reach at the same time. We will not find the exact distance. That's not our concern as of now. Just we are trying to say that both the trains started at the same time. From both the stations, from Delhi, from Chandigarh, the trains started at the same time, but they're not reaching at the same time. Why so? Why did this happen? Because the speed were different. Distance is the same, but speed is different. So they reach the destination at different times. Isn't it? So this is a very familiar scenario. Now see what does the question ask you. What is the question in this? Will this train ever meet or cross each other? Of course, they have to meet each other. And one is going this way and another is going this way. So they will meet somewhere in middle. Somewhere they have to cross each other. We quite often see that trains are crossing each other. One is going this way, another is going this way. The same has been depicted in this picture also here. They are meeting at some place in the middle. We don't know what is that place, but they are meeting somewhere in the middle. So will they meet exactly in the middle? Exactly in the middle means after crossing 165 km, 310 divided by 2, that is equal to 165 km. Let me write in yellow, it will be visible here. Will they meet after 165 kilometers? Will they meet after 165 kilometers exactly in the middle? No. That would have happened only if the speed of the trains were equal. दोनों की speed अगर बराबर होती, if the speed were equal, then they could have met in the middle, exactly in the middle. So how will we calculate where will they meet or at what time will they meet? Can we calculate that? Very simple question. This is a very simple question. So can we calculate when and where will the trains meet? Okay, let's try to solve this question. I'll just remove this question now. We have everything written on the screen now. Now, see, that's the question. One train is moving from Delhi towards Chandigarh, starts at 7 a.m. Speed is 85 km per hour. Another train starts from Chandigarh towards Delhi. Speed is 70 km per hour. Starts at the same time, 7 a.m. They meet somewhere in the middle. Let's say this is the place where they meet. I'll just mark this, say in this color. The trains meet over here at this point. Isn't it? The trains meet at this point. So we need to calculate the distance now or the time now. We need either of the both the things are required. So let's say the trains meet after T hours. After T hours, time is T. Let's say the trains meet after T hours. What will be the distance covered by this train in this T hours? Distance is equal to speed into time. So distance covered by first train is equal to speed, that is 70 km into time T hours. Now, this train is covering this much distance. In what time? Same time T hours. Both are starting at the same time. and they are both are meeting at the same time, so they have to meet. They have to travel the equal time. They have to travel for equal time. And after t hours, this train is here. So in t hours, how much distance this train will cover? D2 is equal to speed 85 into t. ठीक है. So first train is covering 70 into t hours. Second train is covering 85 into t hours. Now what is the total? How will we get anything information from this? How can we get any other information from this? We need, what do we need? We need the time at which the trains meet. How will we get? We need to apply some more, use some more information. That information is 310 kilometers. We have to use this information. How can we use this information? 310 kilometers is the distance between Delhi and Chandigarh. That is the distance between Delhi and Chandigarh, 310 kilometers. Now, out of this 300, one part is covered by one train, another part is covered by another train. So, both, if we add up these distances, this distance plus this distance, what will we get? We will get 310 kilometers. So, that means if we add up D1 plus D2, we will get 310 kilometers. That means 70t plus 85t is equal to 310. What does it mean? 155t is equal to 310. If you don't understand how I will solve it, like, just see it. We will discuss it in lot more details in some time now. So t is equal to 310 divided by 155, that is equal to 2. Means after 2 hours, the trains will meet each other. So when will the trains meet? 2 hours after 7 hours. They start at 7 a.m. So they will meet after 2 hours, that is 9:00 a.m. The trains will meet at 9 a.m. So how did we solve this question? We formed one linear equation. This is what is a linear equation. We formed one linear equation and then we solved it to get the answer. Okay. Now don't say that they are meeting at after 2 hours, so after 2 hours they will reach here. ऐसा नहीं होगा. ऐसा नहीं होगा. They are meeting after 2 hours, तो ये बीच, this is not the midpoint. Midpoint नहीं है ये. Because 2 घंटे में ये ट्रेन कितनी दूर चलेगी? 70 into 2, 140 kilometers. And this train will go 85 into 2, that is 170 kilometers. ये midpoint पे नहीं मिल रहा है. This is not the midpoint. That's why they will not reach the destination at the same time. समझ में आ रही है ना बात? खैर उसमें नहीं उलझना है. We don't have to go into that now. As of now, we just have to understand that this is a linear equation. And solving this linear equation, we get the answer. We cannot get the answer by any other method. So we have seen a linear equation. What was the equation? 70t plus 85t is equal to 310. This is a linear equation. We will talk a lot about such equation in this chapter. So before starting about the details, let's see what is a linear equation and such basic things. So what is the variable over here? We have one variable t, and this is one more variable, and that's also t. So t comes twice in this equation, isn't it? Of course, we can add up both the t's and write, what can we write? 155t is equal to 310. That is also the same linear equation. Both the equations are the same. So the thing to observe here is there is one variable, isn't it? There is one variable. So this entire equation, 70t plus 85t is equal to 310. This entire equation has one variable and there are some operations on some numbers. There are some numbers also. 70 is a number, 85 is a number, 310 is a number, and there is one operation addition over here, and 70t. 70t, what does it mean? 70 into t, isn't it? So there is one multiplication operation involved over here and another multiplication involved over here. So in an equation we have some numbers, some variables, and some mathematical operations also. And then there is one left hand side. There is something on the left hand side of the equal to sign. We divide the equation on this equal to part. Divide the equation on the equal to. There is one left hand side, there is one right hand side. We don't divide the equation on any other point. We cannot divide the equation on this plus sign. We cannot divide it on this multiply sign. We have to divide the equation only and only on the equal to sign. So one is the left hand side, one is the right hand side. Again, these things constitute a linear equation. There has to be one equal to sign. There can be, there may be addition sign or not. Addition sign may be there or may not be there. But there has to be an equal to sign. Multiplication can be there, cannot be there. Can you tell one example without involving multiplication? T plus t is equal to 2 divided by 7 minus 9. See, this is another equation and there is no multiplication involved in this. We have addition, we have subtraction, we have division. So there can be any mathematical operation, but this equal to has to be there. Without equal to, there cannot be an equation. For an equation to exist, there has to be a equal to sign and there has to be one variable also. And of course, there are some numbers also involved. Okay. So equation has these parts. So in this equation can be of different other types also. Can you tell an equation of some other type? Let's remove this. If I say t square plus 9 is equal to 17. This is also an equation. This is also an equation. This is an equation of different type which we don't have to study now. This is not in the syllabus. Why is this not in the syllabus? Because there is a square of the variable involved. This variable is being squared. We cannot square a variable. How can you square a variable? We can calculate 5 square. We can calculate 10 square. We can do all these calculations. But how will you calculate this x square? Can you calculate it? There is no way to calculate it. So we don't touch such kind of equations. In the book you may find such equations which may be discussed in the later classes. But as of now, there cannot be a square of the variable. Okay. The equation can also have more than one variable. Isn't it? The equation may be something like that. 3x is equal to y minus 9. That's also a valid equation. And how many variables are here? X is a variable, y is a variable. So this equation has two variables. We are not going to study any such equations. We are going to study only the equations which have one variable and the power of the variable is 1. So this is what is the meaning of linear equation. Linear equation in one variable. So there are two important terms in this. Linear means degree of the variable is 1. And one variable means there is only one variable. That means we are not going to study the equations like this x square plus x is equal to 9. We are not going to study the variable equations like this x square plus y is equal to 17. We are not going to study the equations like xy plus 3 is equal to 9. All these equations are not going to be studied. So while seeing the question, whenever there is a variable in front of you, equation in front of you, you have to determine whether it is a linear equation or not. Okay. So sometimes it may so happen that there is an equation which says let's say x square plus 3x plus 9, this is equal to x square plus 7x minus 5. Is this equation linear? No, this is not linear because it involves an x square over here and there is an x square over here also. But interestingly, we can cancel out both this x square and we get 3x plus 9 is equal to 7x minus 5. This can be converted into a linear equation. So you know now what is a linear equation. To solve an equation, it has to be linear and it has to have only one variable. If there is more than one variable, it cannot be solved. As simple as that. If the degree of the equation is more than 1, degree is more than 1 means that variable is being square, cube, something like that, x square, x cube or something like that. Any such thing, if it occurs in the equation, we are not going to solve it. If the number of variables is more than 1, we are not going to solve it. Okay. So this consider another equation. 2x plus 3 is equal to 7x plus 9. So there has to be a LHS, left hand side of the equal to sign, LHS. Left hand side of what? Of equal to sign. Left hand side of equal to sign and right hand side of equal to sign. So any equation will have one LHS, one RHS. It will have one variable like this. And there will be degree of the variable. We'll talk in detail about degree more in the coming video. As of now, you just need to know that x cannot be squared, cubed. The variable cannot have any power. Okay. Same variable can occur any number of times. See, the same variable is coming at two places now. X is coming here also and here also. Same variable can come more than once, but there cannot be more than one variable. Variable has to be only and only one. Okay. So in the coming video, we'll talk about the degree of the equation, number of variables of the equations and other things. Okay, thank you.